Welcome to Spring LIB.
For this problem on the topic of periodic motion, we are told that a fisherman hangs a fish of a given mass from an ideal spring. The distance that the spring stretches is given, and we are asked to find the force constant of the spring. We are then told that the fish is pulled downward and released a given distance, and asked to calculate the period of oscillation as well as the maximum speed of the fish. So for the first part, we know that when the fish hangs at rest, the upward spring force Kx is equal to the weight of the fish, mg. So since the system is in equilibrium, mg is equal to Kx, which means to find the spring constant K, we can rearrange, and we get that K is equal to the weight of the fish, mg, divided the distance that the spring stretches, x. And this is its mass, 65 kg, times the acceleration due to gravity, 9.8 meters per square second, divided by the stretch distance of the spring, 0.12 meters. Calculating, we get a spring constant for the spring of 5.31 times 10 to the power 3 newtons per meter. And now we have the spring constant of the spring. Now, secondly, we are told that the fish is pulled down by 5 centimeters and it begins to oscillate with simple harmonic motion. So we are asked firstly to calculate the period of oscillation. Now the period of oscillation t, we know, is 2 pi times the square root of m over k, where m is the mass of the fish. So we can substitute our values and immediately calculate this period. So that's 2 pi times the square root, the mass we know is 65 kg, over the spring constant, which we've calculated as 5.31 times 10 to the 3 newtons per meter. And calculating, we get the period of oscillation of the fish to be 0.695 seconds. So that's our second answer. Now, finally, we want to calculate the maximum speed that the fish will reach whilst oscillating. So Vmax, we know, is omega, the angular frequency, times the amplitude A, which is 2 pi f times A. And this is simply 2 pi times A over the period t, since the frequency is 1 over the period. Again, we have these values, so we can calculate this maximum speed. So that's 2 pi into 0.5 or 0.05 meters, which is the amplitude of oscillations, 5 centimeters, divided by the period, which we calculated to be 0.695 seconds, which gives us the maximum speed that the fish will reach of 0.452 meters per second.